If you're interested in an easy and simple way to heat your home, shop, or office with solar panels, then this video is for you. I have been using solar panels to heat my home for quite a long time. My favorite way is to modify AC space heaters for direct solar PV operation, but that can be quite a lot of work and has a lot of safety risks. There is another way. These heaters are simple, cheap, and easy to hook up. In this video, I will show you how they work, take one apart, explain the inside, and give you a few tips and tricks on operating them for clean, efficient PV to load solar heating. Hi folks, if you've seen my previous videos, you know I'm a big fan of heating my home with solar panels. I've converted a number of AC powered space heaters to direct DC solar power operation. And in the last video I showed part of the work required to modify these AC space heaters to accept a DC solar power input. But some of this work might be a little bit too much for beginners who really don't want to modify AC space heaters, as there are safety risks involved. So I want to present an option for beginners that's a little bit more plug and play and a little bit more accessible. It does the same thing. Heat is heat. Years ago I connected multiple car and truck heaters to my solar panels and used them to heat my bedroom. It was successful and it worked extremely well. The advantages are they are commodity off-the-shelf DC heaters intended for cars and trucks, so not much modification, if any, is required. They are easier to connect and understand. Some of the heaters use what's called positive temperature coefficient elements. More on that later in the video. Okay, so here's a fairly typical car or truck cap heater. You can buy these all over the place. I'm not saying any one is particularly better than the other. This is an example of what I found on online auction sites. These are fairly basic devices. They're not super high quality, and so the same rules that apply with any heater would still apply here. This particular car or truck cab heater, as you can see by looking inside, it's actually a standard wire wound element. It's a little bit hard to see in there. So this is essentially a DC electric heater, low voltage, off the shelf. I would not leave this running unattended, but the fact remains this is a multi-100 watt DC electric heater that is pre-built and is ready to go. So let's go ahead and crack this thing open and take a look at the inside. Okay, so here's what's on the inside. It's actually dirt simple. What you have here is a series of pieces of metal that's been bent into a heatsink. There's a piece of heating element wire which has been wound onto this here, and I'm not going to take this apart or change that or do anything with it. I'm just going to leave it alone. And I got to say that the construction is not the worst I've seen. These fan wires here are frayed a little bit, and they don't look particularly secure. The fans are standard brushless DC fans, so they're very easy to find replacements for. And one of the really obvious upgrades for this type of heater, if you're going to be running it a lot, is actually to get ball bearing fans. These are most likely just normal sleeve bearing fans. Ball bearing fans are more robust and they will last a lot longer. Of course, it's got a rocker switch there, and you know, I wouldn't use this on a daily basis to switch the circuit. I would suggest you use a DC circuit breaker instead and use this switch for convenience only when you need to. So that would be my recommendation. Now this is a 24 volt heater. In theory, you should be able to run this off a solar panel. Now just for educational purposes, it's important to keep in mind that there are different kinds of heaters, and this particular kind is a wire wound heater. It's just got resistance wire. You can see it right in there going back and forth. This is not a PTC or positive temperature coefficient heater. What that means is it's not going to protect itself from overheating. So if these fans ever fail here, very likely that what's going to happen is this heater will burn out. If you're going to have high power on time for this heater and you're going to be running it all day, you're going to want to have good quality fans that aren't going to fail. The upside of this unit is that I would consider it to be serviceable, and you know, it's possible to open it up. Personally, I would be able to replace that heating element if I wanted to. So this is a very simple and robust device. This is very much like a standard AC space heater, except it's a lot smaller and it's designed to run off of a battery. And of course, you could actually run this off a solar panel if you're careful enough. And that's what this video is about. Clean, direct solar heating, direct from the solar panels. But I want it to be simple, and I don't want to spend too much money or spend too much time. Now, of course, one heater is never enough, is it? So I have this heater. This is another one of the ones in my collection. I actually have quite a few of these. Started some time ago. This is years ago. I started using these to heat my home using solar power. This one is a double version. This is actually two heaters added together. They have a mounting bracket on there, and they're pretty much the same exact thing. I'm going to take these two heaters, and I'm simply going to make a triple, just like that. So the brackets already have the holes drilled in them to mount them together. As you can see, that's just a standard mounting bracket for the side. It can be placed right on the top there and bridge these two together, and I'll have a triple wide heater. Now here's a nice piece of information to have. This is a 24 volt heater. It actually says that on the cabinet somewhere. Yeah, right here. 24 volts. Believe it or not, this heater is also a 12 volt heater. And how would I make it a 12 volt heater? Well, the first thing is I would get rid of these skinny wires. You can see these wires are really bad. Those are really skinny. I don't see how those are going to dissipate the power that they claim it can. It's supposed to be several hundred watts. I have a hard time believing that. If you look over here, there's two terminals, and one is positive. You can see the fans. Wow, that crimp looks really bad. The wires are just hanging off. So that's why I open these heaters, is to check the wiring, and I would definitely need to redo this, put some heat shrink or do something. That's terrible. I mean, that fan wire is just hanging on there. Terrible. Anyway, this is your negative, this is your positive. But if you look over here, there's another terminal. Why is that terminal there? Well, because at the factory they want an easy way to make this a 12 volt heater. To make this a 12 volt heater, all you'd have to do is attach your positive or negative to both of these terminals, and then your other wire would go over here to this side. You can actually see there's a terminal right there they haven't used, because this is the 24 volt model. On a heating element, if you're running 24 volts through a heating element, and you connect another wire or a third wire to the middle of that heating element, you will get about half the voltage between those two wires. It's important to understand this because when running off of solar panels, you may achieve a very high voltage and you could burn out your fans. These fans will not accept over voltage, they will burn out quite easily. And if running off a solar panel, sometimes the voltage is higher than you expect, and if that were to happen, you would burn out the fans. There are different ways to protect from this. You can use a DC converter to power the fans, so the fans would be protected and their voltage would be regulated. No matter what voltage comes into the heater, these fans would get the same supply. Another option is to put higher voltage fans in here that can handle the higher voltage. The take-home message here is make sure you have a voltmeter monitoring the overall voltage of your solar panels while the heaters are in operation, because you need to know what those solar panels are doing, and if the voltage is starting to get a bit too high, you would need to know about that right away. Now, I can't account for every single scenario, but the fact is this heater can be made to run off of solar panels. I've done it, it works, but there are a few things you need to keep in mind, and that's what I'm telling you right now. The fans can be burned out. In the middle of the heating element, if you have a connection in the middle, you get about half the voltage. That can be handy to get a half voltage supply. The fans tend to be rather cheap and probably need to be upgraded to ball bearing fans. And nothing like this should be left unattended, and you should always check the crimps and wires before you operate a heater, because more than likely they were done in a hurry, and these are actually pretty sad. I've changed my mind. I really don't like the way they've done it. This is really bad. This will need to be addressed. And you'll notice they have some nice high temperature wrapping on the wires here to protect them, and there's a rocker switch, and instead of using this to turn the heater on and off, you should use an external DC circuit breaker. I'll make it as simple as I can. To connect and switch these heaters on and off, you would use all the same cables, the same circuit breakers, the same bus bars, the same connectivity that you would have used to install your solar charge controller, solar panels, batteries, and inverters. It's important to adhere to the same high standards and quality of installation that you would for any other solar power system. This is no different. You're just cutting out the batteries and the charge controller and the inverter and going straight to the heater. The wiring should be high quality. The connections should be tight. All connections should be fused or at least have a circuit breaker. It's also a good idea to put your heaters on a non-flammable backing board such as cement board. It's the same type of board that's used to install propane heaters inside of a residential building or a shop or garage. It's a non-flammable surface that you can mount the heater directly on. That way, if you ever have a problem with one of the heaters and they catch fire, hopefully it won't burn the structure down. Those are my recommendations. If you're going to use a heater like this to run off of solar panels, your due diligence would involve making sure everything in here is secure, all the wires are good, the crimps are tight, and the more I look at these crimps, the less I trust them. They're actually pretty bad, so I'll have to redo a lot of this if I want to operate this heater. Now, if you want to upgrade your fans, I'm going to use this fan as an example. you simply take the fan and you measure it across the width. So you would measure from here to here. You can see that this is a 40 millimeter fan that I'm using as an example. In this heater cabinet, the depth doesn't matter so much, but that would be this dimension here. As you can see, this one's about 10 millimeters. So this is a 40 by 10 millimeter brushless DC fan, and you would simply measure the fan that you want to replace, and you can see they can be wider or narrower, that doesn't matter. But you would need to measure from here to get the right size. And I would replace these with nice high quality ball bearing fans with long life. Now just a quick explanation here of how heating elements work. If you're going to run these heating elements off of solar panels, let's just draw the sun here and a set of solar panels here. There's your battery, there's the solar panels, and the heater doesn't really care which one it is, but a solar panel is going to have a wider voltage swing. Let's just assume that I'm running off of around 36 volts, so we'll just say 36 volts. You know, a solar panel will probably be around 30 volts. If it's a 12 volt solar panel, you know, it could be 16 volts. You will have to decide what voltage you're going to run at and choose the heaters appropriately. But regardless, there are some principles you need to understand. One of the hardest tasks is trying to match the heater or heaters you're going to use to the solar panel's maximum power point that it wants to run at. If you put too heavy of a heater on the solar panels, it will pull the voltage down too low and you won't get very much heat. So some of this is just going to be trial and error, unfortunately. Let's draw a diagram of the 24 volt heater. So that heater actually consists of a heating element, and we'll just draw that as a curly line. There's a midpoint. So these two heating elements are actually two separate elements, and there's a midpoint. In the heater I showed you, this midpoint is not being used. These two connections are being used, and it's a 24 volt heater. But you could also make the argument that it's two heaters. It's actually two 12 volt heaters in series, and that gives you 24 volts. So it's important to understand, if I feed a 24 volt supply into here, and I put DC in, let's say this is positive, and I put DC into there, it comes over here, and by the time it gets here, it's dropped about half its voltage. When it comes over here to this side, we'll call this the negative, then it's going to be about 0 volts. So it's dropped all the 24 volts over the heating element, and that causes the heating element to get hot, and that's how it works. You could also say that a heater running off a solar panel is nothing more than a controlled short circuit of those solar panels, causing the wire to get hot and generate heat. So it's important to understand that in the middle of this heating element, where the middle part is, it's actually half voltage. Now that's a rough statement. It could be 13 volts here and 11 volts here. We don't really know. In order to find that out, you would take your multimeter and you would connect it right here. And you can measure between these points here, and you can get your voltage. Now that voltage might vary, and it's not a regulated supply, but here's where I'm going with this. Solar panels often have a very wide voltage range. You can't really say the solar panels are 24 volts per se, because their voltage can be much higher than 24 volts. And that brings in another problem. These fans that are typically inside these heaters aren't able to handle wide voltage swings. If they go over voltage, they will instantly burn out. It's true that you can run them a little over, it depends on the fan, but I've personally burned these out on solar panels and I know they burn out, so thankfully they're fairly easy to replace and they're fairly cheap in most cases. Just to make it clear, if this is a heater, and I'm getting 24 volts here and here, if I move my probes over to here, I should be getting about half voltage, and the same for here. Now, polarity, this is the most negative side of the circuit, so this will be your negative, this will be your positive, because for this section here, this side here is the most positive point of the circuit. So that would be your positive. So you could actually write a positive sign here, then you can write a negative sign here. And this may seem a little confusing, but it's really a basic principle. It's something you should probably understand if you're going to get into DC heating, PV heating. This is the negative because this direction is the most negative side of the circuit. That's where your negative wire is connected. It's in this direction. If you're operating this heating element here, this is your positive and this is your negative, because in this direction is the most positive side of the circuit. So if I want to measure about half the voltage, I can put my probes here and here. It doesn't really matter the polarity, the meter will make that up. I can determine what voltage I'm getting while this heating element is under operation. Now, why is this principle so useful? It's the fans. If you're running off of a solar panel, you may actually run across a condition where the voltage across this heating element is too uncontrollable for these fans to operate safely. What you can do is you can actually take this fan and you can run it off of half the heating element. So I would connect my fan to this part of the heating element using the midpoint and one terminal. Of course, you got to get the polarity correct or that will burn out the fan as well. So this gives you an additional option. If running off of solar panels, you may run across this condition where you need to have less voltage. Another option for protecting your fans is a DC-DC converter. Now the fans take very little power, so a DC converter like this, as long as it can handle the input voltage of the solar panels, should be able to run multiple fans no problem. I've done it for years, it works fine, and I do recommend it. Now if I was trying to run in a slightly higher voltage than 24 volts, what I could actually do is I could add an additional heater in series, say a 12 volt heater. Now I would have a 36 volt heater. So a 36 volt heater is going to be a little more tolerant to the higher voltage of a solar panel. If you're running 24 volt panels, those are going to put out a little more voltage than you might expect. In many cases, they can be far over 30 volts. If I wanted to run my fans in a way that they're very safe and protected, I can simply take the voltage off any one of these coils here, these heating elements, and feed it into a DC converter of any kind. Doesn't matter. A DC converter. This is just an example. There's so many DC converters, that's another video. And then I can plug my fan into that DC converter and have a safe and regulated voltage supply. If the DC converter supports a high enough voltage, I can take it from positive and negative here. Or I could pull it off of one of these coils, which in effect are acting like a voltage divider. So these heating elements are actually potentially able to be a voltage divider. And that's what I'm showing you here. This is literally a voltage divider, a resistor voltage divider. Because each heating element is in fact a resistor. That is how they work. Now if you're interested in learning about what is termed Ohm's law, or I call it Ohm's formula, it's very important to understand that formula and learn how to use it. If you want to move up to a higher level of understanding, I would suggest you look into Ohm's formula, or what is called Ohm's law, and that will allow you to calculate the voltage and the resistance and the power dissipation of these heating elements. Now you don't have to do that in order to operate these heaters. I'm just showing you the inside because I think it's important to understand what's inside, and that's a safer way to operate. Having a better knowledge of what's going on inside these heaters is going to increase your safety level. If you want to learn about Ohm's formula, I'm going to write an example here. Now these are the three formulas I use in my practice of using solar energy. They're very useful. If you want to learn more about them, check out my part 2 of the electric space heater series. I'll put a link in the description and on this video. And in that video I explain how to use this math system to calculate the performance of different types of heating elements using math and using the resistance. You can actually measure that with an ohm meter. So if you have a meter like this, any kind of ohm meter will do. It doesn't need to be fancy. You can actually take this meter and measure across these heating elements and calculate what their dissipation will be. Of course, nothing works like it does on a sheet of paper, but you can actually do a pretty good prediction of what these heating elements will do using a simple math formula, a multimeter, and some basic calculations to give you a really good idea of what's going to happen with these heating elements. Okay, enough theory. Let's take this heater over to the bench and hook it up to some solar panels and make sure that it's working properly. It's not the best thing to look at, but here's my test setup. What I've done is I've taken this 12 volt heater here and I've cut the parallel connections on the input and I've turned it into a 24 volt heater. Next I've taken this other heater, which was a 24 volt heater, and I've placed it in series with this heater. And that's going to give me effectively a 48 volt heater. And that's okay with me because I want to run it at a lower power output than it was originally intended. And I may change that later, but for right now I think this will suit me fine. Now unfortunately it's a little bit too early in the morning for these heaters to run, and I'm only getting about 15 volts into my heaters. That's one of the problems with PV solar heating, is in the morning and in the evening you don't get a lot of heat. But I'm not too worried about it. I'm just going to wait for the sun to come up and see what these heaters can do. I will say this though, the fans are already turning. I got 6 fans. It's a little bit hard to see these. You can see they are turning, except for that one there is a little bit slow. And that one there just stopped. So there really isn't enough voltage to get these all these fans running yet. However, there is heat coming out. I'm actually feeling heat. Yeah, this heater is getting hot. This one here is putting out heat. So they're getting warm. They're putting a little bit of heat out, but it's still too early in the morning to get the full power. And now the fans are spinning. All 6 of them are spinning. So I'm just going to wait a little bit longer and see how much heat I get out of these things. Okay, there's my triple decker heater I built. And as you can see, the side brackets are double purpose. They actually allow you to attach the heaters together. They're pre-drilled. And these heaters are available everywhere. I don't know if they all have these types of brackets on them or not. You can look at the pictures to see. But all you have to do is take the brackets off and mount them on the top, and you could, ideally, I guess you could stack 4 or 5 of these together if you wanted to. Yeah, it looks pretty powerful. Okay, they're up and running. I have the 3 heaters linked together. It's about a 40 volt heater, something like that. It varies. And my voltage is coming up a little bit higher. I need to be up around 30 plus volts, maybe 40 volts, in order to get the heat output I'm looking for. And the sun is starting to kind of get stronger, as you can see. The voltage is beginning to go up. There we go, over 20 volts. Still not producing much heat, but once I get into the 40 volt range, I think it'll be producing a nice amount of heat. Let's see if the fans are running. Yeah, they are spinning. It's hard to see, but yes, they're spinning. And there goes the sun going dim again. So it's still early morning. I'm going to leave these running under supervision and see what happens when the sun comes out. Hopefully I'll get some good heat. Okay, we're in business now. As you can see, this one here is running at a higher power output, and it's actually lighting up a little bit. Voltage is a lot better, 39 volts. I'll still need to work on balancing these heaters because they're not balanced. They're actually different heaters, but I don't mind. Still works. Let's see what kind of heat we're getting coming out. Getting pretty hot. The housing is relatively cool. It's about 90 degrees, which isn't too bad. Well, it's 100 degrees over here. So it can't get any simpler than this. You take your solar panels and you plug them into your heaters and you get heat. Of course, these things have fans in them and they're quite loud. It's not too bad though. And you could always use better quality, quieter fans if you wanted to. But this is good because you don't wear out your inverter, your batteries, your charge controller. It doesn't make sense to burn your battery and charge controller and your inverter just to simply make heat off of PV. It just doesn't make sense. So here I'm actually using simple resistance heaters with fans to heat my house, or in this case my shop. Here are some smaller PTC elements I bought out of curiosity, and these are running off of a smaller solar array of 100 watt solar panels. These are supposedly 24 volt PTC heating elements, but some of them don't seem to have the correct resistance, and I wanted to run at a higher voltage. As you can see, I fixed this by rewiring them as a voltage divider to run the DC fan at a lower voltage and accept a higher voltage on the heating element itself. This modification was actually very successful, and I've done it multiple times. Some of the knowledge presented in my prior video about modifying AC space heaters does apply to PTC heaters, but this is a much easier option for people who don't want to go to all that trouble and work. Here is how these PTC heating elements work. They have a certain resistance in ohms. When a DC current circulates from a solar panel or battery, they get hot. The hotter they get, the more resistance they have, which reduces the heating. So they need a fan to cool them or extract the heat so they don't throttle down. This is a bonus safety feature that PTC elements have. If running the heating element off of a solar panel directly, one must be very careful not to expose the DC fan to excess voltage. This can burn the fan out easily. In my case, you can see here that my heating elements are wired in such a way that the DC fan is only connecting over half of the element instead of being in parallel with the entire element. This acts as what's called a voltage divider. A voltage divider will basically give you only a portion of the voltage that's circulating throughout the set of resistors. In this case, the resistors are a heating element, but it doesn't matter. It works exactly the same way. So to try to make this simpler, if you want to heat your home with PTC heating elements running directly off of solar panels, PV to load, you may run into a case where the fan cannot handle the high initial voltage from the solar panels. You can get around this by simply wiring the fan over only a part of the heating element and reducing the voltage that it actually sees across the heating element. Please note that my example shows 12 volts across the entire heating element and 6 volts across each half, but it doesn't matter what the voltage is. It's all the same. The numbers I picked are arbitrary. The resistance is arbitrary. The principle is exactly the same no matter what kind of heating element. If you place somewhere in the middle of a heating element a connection, you will get about half of the voltage that's circulating off of that heating element, and this is a very useful way to run fans and other loads at a lower voltage with basically no electronic components whatsoever. In summary, I hope this video helps beginners who really don't want to modify AC space heaters to heat their home off of solar panels, but would rather have some other option that's probably a bit simpler and a bit safer. Hopefully it's enough information to get you started. If it's not, feel free to leave me a comment and let me know what you want to see addressed, and perhaps I can follow up with another video. If this video helped you out, please give it a thumbs up. Thanks for watching, and I'll see you later.